In this unit, you've already learned how to solve average atomic mass problems. Today, you'll be learning how to use these types of problems with a systems of equations approach. In these types of problems, you'll always have two different types of equations. The first equation is quite simple. It simply has to do with the percent frequency of each isotope of the element. Let's say we have two isotopes of a certain element, A and B. We know that we have 60% of isotope A out in the world and 40% of isotope B that's naturally occurring. Given these percentages, we can convert them into frequencies quite simply. In order to convert a percentage to a frequency, all you do is you simply take the percentage divided by 100. You can also think of it as moving the decimal point over 2 to the left. So a percentage of 60, for example, would correspond to a frequency of 0.6, and 40% would correspond to a frequency of 0.4. So if we wanted to write an equation that showed the percent frequency of these two elements, we would simply write it as the frequency of A, isotope A, plus the frequency of isotope B equals 1. Now, that's something to notice. Just as the percentage of any two given isotopes of an element will always add up to 100%, you can be sure that the frequency will always add up to 1. And as you can see in this case, it's quite obvious. 0.6 plus 0.4 does indeed equal 1. The second type of equation involves both the average atomic mass, it involves both the individual mass of each isotope and the percent frequency of that isotope added together to give you the average atomic mass of the element. You've already encountered these types of equations. They look something like this. So for this one, for example, we would have a mass of isotope A. We would take that times the frequency of isotope A, which we know is 0.6, and we would add that to the mass of isotope B times the frequency of isotope B. And these added together would give you the average atomic mass of the element. These two types of equations, the one where you add up the frequencies of the two isotopes together to make a whole, or one, and the equation where you add the mass of each isotope times its frequency together to find the average atomic mass of the element, will both be needed in order to solve these types of problems. Now let's consider boron as an example. The problem tells us that there are two known isotopes of boron, boron 10 and boron 11. That means that boron 10 has an atomic mass of 10 AMU and boron 11 has an atomic mass of 11 AMU. Now from the periodic table, we also know that the average atomic mass of boron is about 10.8 atomic mass units. Given this information, we can write both of the equations that we need to solve the problem. The first one involves adding the frequency of both isotopes to get a total of 1. Because we remember, just as frequencies always add to 1, percents always add to 100, as long as we know both of the isotopes. In this case, we don't know anything about the frequencies, so we're going to assign those as our variables or our unknowns in the problem. Let's call the frequency of boron 10 X and the frequency of boron 11 Y. It doesn't really matter what variable you use, but these are pretty standard ones, so I'll use that for our example. Now we know that X plus Y is going to add up to 1 because the frequencies of the two isotopes, of course, is going to add to 1. That's our first equation. The second equation just involves taking the mass of each isotope times its frequency and then adding those together to get the average atomic mass. So in this case, first we'll take the mass of boron 10, which is 10 AMU, times X, plus the mass of boron 11, which is just 11 AMU, times the frequency of boron 11, which is just Y. And we know these are going to add to the average atomic mass, which is 10.8. Now we have our two equations set up for our system of equations. The next step just involves combining these two equations so that we can find our answer. The easiest way to do this is simply to solve for one of the variables in one of the problems, or one of the equations rather, and then substitute it into the second equation and solve. In this case, it's probably easiest to use this equation to solve since it's so simple. So I'll just take one of the variables over to the other side. Let's take y over. So we'll have x equals 1 minus y. We've now solved for x, so we can just substitute 1 minus y in for x into this equation. So now I'm going to do it over here, and I'm just going to write 10 times 1 minus y, substituting that in, plus 11y equals 10.8. Now I just need to distribute my 10. So 10 times 1 is just going to be 10. 10 times negative y is going to be minus 10y. This is a 0. Plus 11y equals 10.8. Now I just need to combine like terms and solve for y. So combining negative 10y and 11y, I'm just going to get regular old y. Now I just need to get y by itself, so I'll subtract 10 from both sides. And I get y equals 0.8. So y, remember, is the frequency of boron 11. I now know the frequency of boron 11 is 0.8. In order to find the frequency of boron 10, I just need to plug in for y into either one of the equations and solve for x. This is probably the easiest one. So we'll just do x plus 0.8 equals 1. Then we just subtract 0.8 from both sides, and we get x equals 0.2. So we now know that the frequency of boron 10 is 0.2. Now, just like you can divide by 100 to go from a percent to a frequency, you can multiply by 100 to go from a frequency to a percent. So 0.2 times 100 is 20%, which is the percentage of boron 10, and 0.8 times 100 is 80%. So now you know how to solve average atomic mass problems using systems of equations. Okay, I think I